Hello, 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 JSConf US. Thank you for having us. Welcome to the last talk of JSConf US. Very exciting. One of two things has happened. Either we've saved the best for last, or they've pushed all the crap to the end. We're not really sure which, but I think we're about to find out. But let's be honest, y'all don't want to do this. You don't want to know this, do you? Let's not do this. We'll just go straight to the party. You don't want to do this. Come on.
Just get in the hot tub. Yeah.
Who cares? Yes, so welcome to, what is this called? Discovering the True Identity of Horse.js using machine learning. I'm Burke, and this is Jasmine. Jasmine, we're going to pass this back and forth here.
Yeah. So we work at Microsoft. We work on the Azure team. And one of the things, actually, before we start, do you want to just tell a little bit about yourself, Burke? Specifically your shirt.
Oh, sure. So I have a show called 5 Things that we do. Anybody here seen the show 5 Things? Right. So I think I work with most of these folks. Thank you for being here. We have literally dozens of viewers. It's the hottest show on YouTube. We have at least 2 comments across 17 videos. Yeah, that's me. I'm from Nashville, Tennessee. So on behalf of all the web developers in Nashville, thank you for having me.
Yeah, and as I mentioned before, I'm from New York. I'm from New York, but I lived in Florida. So I was really excited to come hang out at JSConf 2015 when that happened. And I just recently learned that I'm seeing Empire.js, so that's going to be held in New York City. So I'm excited. We, like I said, mentioned before, we're on the Azure team at Microsoft, and one of the things that our team does for training is we have these boot camps. A lot of us have backgrounds that are not in Azure, or sometimes not even in with cloud technology. So it's just a great time for us to get to learn about the platform, learn about the cloud, and also a chance for us, our team, to get to meet each other in real life, because we are a globally distributed remote team. So we don't get to see each other in person at all, or often. So this is pretty much where the story starts, right, Burke?
Yeah, absolutely. So Jasmine makes a good point. We're actually not on the same team. We're in the same organization, but Microsoft is sort of a largish company. So when we say organization, we mean like a small country. And so we work on different teams inside of the same organization. We were at this boot camp, and this idea, like most great ideas, was born of pure boredom. So we were in this class on artificial intelligence and machine learning, and it was a real deep dive into actually building models. We'd been there for 2 days. This is day 2. We're sitting in the back. We're highly caffeinated. We've been eating Google clusters all day. If you don't know what that is, see me later. I'll explain to you the glory of a Google cluster. And we stopped paying attention, as one does, at the end of 2 days of workshop. Actually, I had stopped paying attention at about 10 a.m. on day 1. That's a problem. I should probably get some medicine for that. I'm going to look into that. But we're sitting there talking about machine learning, and we said, what if we could use this great power to do some real good? Things like discovering the true identity of the Horse.js Twitter account. And so we had this idea that we could take a bunch of data and we could just stick it up in the cloud, and then we could just say, like, Alexa, who is Horse.js? And it would just tell us, because that's how machine learning works. Of course, everybody knows that. And so that's how the idea came about. But what is Horse.js, for those who don't know, Jasmine?
Yeah, sure. Did you want to explain who Horse.js is?
Yeah, sure, absolutely can. Obviously, we've rehearsed this many times. We have it down to a science. So Horse.js is a parody account on Twitter, and what it does is it takes fragments of other people's tweets and it tweets them out. And of course, there's no context. It's taken completely out of context. And so when you see the Horse.js tweet, right, like, that's great. And a lot of times it's almost poetic, right? You're like, oh, that's exactly how I was feeling right now. So it's this weird sort of effect. And it actually comes from a viral account called Horse eBooks. if you're familiar with that, which was started by a fellow in Russia who later actually sold that Twitter account to someone. It got so popular. And so we've been following this account, both of us have, and we really enjoy this. Right? I get a lot of joy out of what is Horse.js going to say next? Nobody knows.
Right.
And so from that was born the project, which we called
Project Horse.
Yeah.
So,
naming things is hard. Naming things is hard.
Right. So we're gonna talk a little bit about the story of how we went through the process of with Project Horse. So first thing we did is we gathered some questions other than just who is Horse.js. We had some additional questions to kind of give us some clues as to who it might be and to give us an end result. And then from those questions, we started drawing some assumptions, some things that we already knew about, like Twitter users and the tech Twitterverse, or the JavaScript Twitterverse, and the people we knew. And so from that, we had some assumptions, and then finally we moved on to planning, trying to figure out what technology we should use, trying to figure out what our end goal was, and trying to figure out how to even get started. And then we're going to talk about how we pretty much built Project Horse, and then finally we'll talk about the results, and we'll talk about and we'll expose to you exactly who Horse.js is. Now, I've heard that people have been saying if they don't say who Horse.js is, I'm gonna freak out. They better not say something like, "Oh, we're all Horse.js." Oh, yeah.
See, you're laughing because you said it. We know you said it.
Yeah, exactly. And that, that's kind of a given, right? We all owe Horse.js. Horse.js's content is, pretty much it's us. And like when you saw that tweet, you chuckled a little because you can identify with that. That whole "I think therefore I am" thing, right? But before we even get into the results, we want to make sure that we don't put the cart before the horse. Thanks,
You're
Daniel,
welcome.
wherever
That's
you
free.
are.
That one's for free.
First we're going to look at the questions that we had. So the first question that we had is, we want to figure out, is Horse.js more than one person? I thought Horse.js might have been a bot. And so at first I was like, should we even do this? Maybe it's just a bot. Maybe we should just move on. Maybe there's nothing here. And then also again, Horse.js has been around since 2012, I believe, and has over 7,000 tweets. So we were like, that's a lot of content to keep up with. Can it really be just one person? So the other question we had was, what tweets does Horse.js react to? What makes Horse.js want to quote your tweet? What do you have to say to make Horse.js, other than the word JavaScript, right? To have Horse.js react to your tweet or quote your tweet. We also wanted to know when Horse.js was the most active, because that could be some clues that expose who this person might be. And then also, we want to know if there are certain accounts that Horse.js liked to react to, and figure out if that can kind of give us some clues as to if they're followers or if they are actually following Horse.js. And then finally, we wanted to check if Horse has ever slipped up in maintaining their anonymity, because for any given crime, there are an average of 20 mistakes made that point directly to the perpetrator. So we were hoping that we'd find something good in that data set.
That's actually a true fact. If you're thinking of committing a crime, just know, statistically speaking, there are 20 things that you will forget about that will point directly to you, and you will be caught thusly. So that's what you're hoping for. Yeah.
Right, exactly. So from those questions, then we started to think about our assumptions. And you want to talk a little bit about that?
Sure. So we had to go into this whole thing with a certain amount of assumptions. You have to start from somewhere. So, after sort of the question phase here, we moved into forming some solid assumptions off of which we could sort of move forward and actually do something here. What we're doing here is very much sort of a forensic analysis, which is why it gets very interesting. So the assumptions that we had here, the first one is that Horse is an actual Twitter user. Okay, whoever's behind Horse is also an active Twitter user. It is not a bot. If it were a bot, it would be very hard to catch because it does not exist. And so we started with this assumption that that was the case. We didn't know that, but we had to assume that to move forward. The second thing that we assumed is that Horse.js is a web developer, a JavaScript developer, a Node developer. They are not someone who is outside the industry, right? It's not a real estate agent who works all day selling houses and then on the side is tweeting out things about JavaScript. If you are a real estate agent and you're here, welcome. We're glad you're here. But we just figured that was not you. So that was an assumption that we made there about Horse.js. Important. Another one that we made is that the person behind Horse.js is probably following Horse.js. Have you ever heard this one? The person who commits the crime often returns to the scene of the crime. Have you heard that before? There's a lot of crime analogies in here. That's very true. And we figured that whoever Horse.js is, they probably cannot help but seeing themselves in their own timeline and chuckling at the cleverness of what they have just birthed to the world. And so we assume that they are there following that account because they just can't help themselves. We're sort of developing a psychological profile here. The other assumption we made is that Horse.js is a single person. Now, I don't mean like Horse.js doesn't date. I mean like it's just one. I just want to clarify that first. I don't think that has anything to do with Horse.js. If Horse.js is more than one person, and actually I should clarify here, we actually operated under different assumptions here. Yes. You were pretty sure that it was more than one person, and I was pretty sure that it was only one person. Part of the reason why I was sure of that is because I wanted that to be the case. This is how my life works, how I engage with reality. And so if you think about it, if Horse.js is one person, that makes it a relatively straightforward task in terms of trying to find who it is. If it's more than one person, now your analysis has an exponent on it, and the logic tree has a ton more branches in it, and there's a ton more things that you have to chase down. So actually finding one person would be much, much, much easier than trying to find multiple people. Trying to solve crimes where there's multiple perpetrators involved is incredibly difficult to do. Another assumption that we made is that Horse.js is not using a private list. And this is another one where we sort of disagreed kind of throughout. Jasmine thought that they were. I didn't know what a private list was because I don't know how to use Twitter, apparently. But apparently you can have a list of people that you follow that other people can't see. And so if you go to the Horse.js Twitter account, they're not following anyone. They're following an account called Horse Context that hasn't tweeted in years. And so I assumed that that account wasn't following anyone specifically, but that whoever was behind Horse.js, what was happening was they're on the internet, they're on Twitter, they're like, ha ha ha, and then they turn over to this other account, the Horse account, and then they tweet it out. That was the assumption. And then the last assumption we made, the most important one, is that machine learning is the answer to everything. It's like SharePoint. It solves all your problems. Hey, can we cut that joke out of the video? No, I'm just kidding. Leave it in. And so, again, we're JavaScript developers. We don't know anything about machine learning. We're not data scientists, right? We're just trying to use it because everybody's talking about it, and they won't shut up about it. So here we are. Let's make it work. Can it solve this problem? So those were the assumptions that we made. And then the most important question that we had to ask at this point was, how in the world are we going to do this? We used to have these calls when we were first starting out where we would just sit there and talk for like 30 minutes to an hour, and at the end of the discussion, we just had nothing. Right,
like by the end of it, like we would know what conferences that we were going to and like, how our summer is going, but we didn't really
Other than that, I was starting to get really, really worried because after we had submitted the abstract, we submitted the abstract to JSConf US, they said, hey, congratulations. And I called Jasmine and I said, oh crap,
yeah,
I got some bad news.
I was hoping for a nay, but they said yay.
Because so we had to get started, and we did not know how to get started. This was actually the hardest part of the whole project. Fortunately, there's this guy. Yeah, Vadim. Susan knows. This is Vadim. This is actually Dr. Vadim. Vadim works on the Azure team, and he has a PhD in computational biophysics. I have a bachelor's of science in business administration. Vadim is slightly more qualified than me to solve this problem. So when we sat down and we met with Vadim, I explained to him what we were trying to do, and he said, okay, and what is your data set? And I said, it's Twitter. All of Twitter is the data set. It was like, ooh. And then he told me something that completely sort of changed the trajectory of this project. And what he said was, you don't have a machine learning problem, you have a statistics problem. Now, what I didn't understand about machine learning is that what machine learning does is it takes statistical models that you have already created, and it crunches those models to then make predictions about what might happen in the future. So for instance, you could take all of the data about Horse.js, all the times that it's tweeted, and then what machine learning can do is tell you, based on this pattern, it's probably going to tweet again at this time. What machine learning is not going to do is create the model for you and give you the answer. That just does not work. And so what we had to do here was really not about machine learning as much as it was about data and data science. There is another person who works at Microsoft. I actually don't know where this guy works. This is Matt Veloso. I'm not sure where he is in the organization. But he tweeted this, and I was like, oh. If you take one thing from this presentation, so the next time somebody at your company goes, we need machine learning, like, wait, maybe you don't. You might just need a regular old query.
Tell them, hold your horses. You just might need a query.
I wish I could say that was the last one, but it's probably not.
No.
All right. So this is a really important fact, and one thing that I think that you're going to take away from this presentation is that machine learning is very powerful, it's very interesting, it's a very remarkable technology, but you plug it in when you need it. And I think the thing that we all struggle with is, when do I need it? And the answer is, I don't know. But as we walk through this presentation, we're going to get to a point where we actually do use some machine learning, and you'll see that it's just one piece of the puzzle, okay? So a lot of the things that you can do, you still do those things, but there's going to be that one thing where you're like, we would need an army of people to do this, and it's one thing, and that's where you plug machine learning in. That's the hole that it fills. So with that, we're ready to get started.
Yeah.
So what do we do?
Well, first thing we wanted to do was grab all these tweets and put them in a data store. Now, the challenge was trying to figure out how far back we wanted to go and how many tweets did we want to collect. So to help us with this, we use this account called HorsePlaneJS. Thanks to Patricia, wherever you are. Thank you for informing us about this account. This was really helpful because what Horseplane does is for every Horse.js tweet, Horseplane comes in and mentions the originator of a tweet and then quotes the actual tweet that they posted.
Yes, thank you very much. Was it Patricia you said?
Yeah, Patricia
yes,
Galena, wherever she is.
Thank you. And
thank you.
Yeah, Horseplane has ratted you out. Let me just tell you, because if it wasn't for this account, there is no way we could have gotten started.
It would have been so difficult.
Yes.
So we're like thinking, okay, how do we get started? Of course, we need to use Twitter API to grab this data and put it in a data store. But what do we build? What do we use to do that? So we thought of a serverless solution, which is on the top left here in this graph, called Azure Functions. It's Azure's serverless solution that allows you to do event-driven code execution. We're at Microsoft, we have a bunch of credits, so it was the fastest, cheapest way for us to do it. We worked on it.
This is like the greatest thing about working there is you just have like all of Azure. Like I'll just take that whole data center for my project for JSConf.
Oh,
That's
yeah.
mine.
The
East
VM
US, we've got it.
Right? So and then we use that to get or connect to the Twitter API. We use the free 99 version of that, which can cause a few rate limiting issues, and I'll talk a little bit about that in the next slide of how we overcame that. And then we put that into a data store, and then we used also Cognitive Services Text API to do some text analytics on some of the tweets. And then out of all that was consumed by graph through for Horse.js to figure out what the results are, what the result set was, so we can kind of make sense of all this data.
And one of the important things here is that this is just the API, and this took most of the time, almost the entirety of our time was spent just building the API, which is, I feel like, how everything else goes, right? Like 80% of the work is spent doing something that nobody ever sees, but it's got to be done. We also learned some interesting things about MongoDB, because Cosmos DB uses the MongoDB API. I didn't know much about it. I still don't. I'd send Jasmine a message and be like, can you please run this aggregation query? I have no idea what's going on here. And she'd be like, sure. And yeah.
My browser history for the last 2 months has been fascinating. It's all the MongoDB documentation.
Yeah, mine is like every Stack Overflow post on MongoDB ever. I've been there. I've been to every single one. So we learned a lot. It was very, very difficult, and there were a lot of times we just wanted to quit.
Right. Yeah. But how can you quit when you have free credits, right?
That's exactly right.
So just to talk a little about the Azure function that we use this function. We called it our function app horse hunt, because obviously we're hunting for a horse. And what the function app does is it hosts our functions, and then it's also a place where you can add configuration file, configuration. So for example, the Twitter API, you need keys, you need token keys,
consumer secrets, blood of your firstborn child.
Yes, yeah,
blood of
exactly. And so the nice thing about that is that you have one place to add your configuration, and then all your functions already have access to all of that. So you don't have to copy and paste it billions of times for your functions to work with the API or whatever else you're connecting it to. So we used two event-based functions. The first one is the timer event function, and what that does, it would run. We had one that ran at 1 a.m. Every day, and it would collect the tweets from the prior day, that Horse.js that we didn't have in our data store yet from the prior day, and dump that into our Cosmos DB instance. And then we came with the challenge of backfilling, going back as far as we could. We went back as far as the Horseplane JS account did, so that we could kind of easily run our queries and compare the original tweets and the horse tweets. With that was where we really came across some rate limiting issues. So we had a timer trigger, or a timer triggered function that would run on a schedule, and it's really easy to set up. You just do it with a cron job, and it stopped, and eventually it was done when we told it to stop. We gave it a few dates. Dates in time, and collected as many tweets as we could, and then once that was done, we shut it off, and it's literally as easy as a click of a button. And then when we wanted to consume that data, we used an HTTP event function, and that was what we used to get all of our outputs for our queries and our results. So when it comes to in the end, like Burke said, we just pretty much built an API that collects the data, puts it in the data store, and then also to query that data. Now for Cosmos DB, so Cosmos DB is a implementation of Document DB, I believe, and the nice thing about it is that the documents, your document structure will all look the same, but the thing that differs is the API that you use to consume your data with. So there's different options. For example, there's SQL, Cassandra.
There's a graph Gremlin API, yeah.
Yeah, there's all kinds of stuff. The one we use, as Burke mentioned before, was MongoDB. And in these two screenshots here, it's just an example of what the structure kind of looked like. So we had a horse object, and that would contain the horse.js tweet and some additional metadata. By the way, which was like completely empty. Horse.js is really good at covering their tracks. And then we had an original object, which also had the original tweet and some additional metadata in that. And then initially, aside from also consuming the data and like running queries to put in charts and stuff to make sense of this data, we also used the Cognitive Services API, specifically their text analytics API, to run some analysis on the tweets. So Cognitive Services is pretty much the AI and ML that we don't have to do. We just it's pretty much just an API. It has an endpoint. You give it some data or you give it some info, and it spits out or returns something back to you. And the nice thing about that is that we don't have to build our models. We didn't have to do anything. We just had to hit an API endpoint, which is really nice. So what you're looking at here is the demo site for the text analytics API. And what's happening here is that this demo, you put in some text, and if you can see here that I have a text or a tweet from one of the data store, or from one of the text from one of the tweets that was from an one of the original tweets in our Cosmos DB instance. And to the right there, we see it's measuring things like sentiment and keywords and things like that. And then on the bottom here, is an example of what it looks like in our database, or in our database collection, or in our collection, excuse me. And what we pretty much really ended up using was the keywords. The sentiment was kind of cool, and what sentiment does is it pretty much measures whether or not text is positive or negative. So anything above 50% would be perceived as positive. Anything below that's negative. And we didn't really use that, but the keywords really came in handy for us.
Right. Yeah, and you'll see that here in a bit how we use that. But that was interesting because the sentiment is sort of what you think it would be used for, but that's not actually what we used it. We used it for key phrase recognition, right, which you would otherwise have to do by hand, right? That would not be fun.
Exactly, and we did discover that using the sentiment analysis on horse.js wasn't going to work at all because
a lot of it's just nonsense or sarcasm, and computers, as it turns out, are not great with sarcasm. True story.
Right, and in fact, some of the horse.js tweets actually broke some of our functions when we tried to get text analysis on it, because even like the text API would say, I don't know what this is 2 words. Why are those 2 words?
This is not a sentence.
This is not a sentence. Like this is not coherent. I can't help. So with that, with all that stuff, we finally started to make sense of our data. We started to work on some of the results. So Burke, you want to talk a little bit about those results?
All right. You don't want to talk about results, do you? I don't want to see this. And you're like, yes. Why did you waste so much time already? All right. Okay. Let's do it then. All right. So here are the results from all of the work that we did, all of the weeks of sifting through this data. Here we go. The first analysis that we did is something called a time series analysis. Now, I'm about to make some broad and inaccurate statements about the study of statistics, because I am not an expert in statistics, so don't at me. If you want to come see me later at the party and explain why I'm wrong, I will be happy to hear you out. But for the purposes of this talk, grant me some leniency here as I say some horribly wrong things. Here we go. A time series analysis is when you look at a series of events as they occur over a period of time. It's actually quite simple. I can't wait to hear how that was so terribly wrong, but I'm sure I messed that up. So the first thing that we did was we took all of the horse.js tweets and we looked at them over a period of time. So let's do that. This is a graph a scatter of every single horse.js tweet that we had in the database. Something should pop out to you right away. What do you see? They sleep. Ah, are they really a developer then? Now this is where this really starts to get interesting, because what you're going to see is the same thing we saw, which is that we would go in with these assumptions, and then we would run these queries and look at these graphs and have completely different realizations. So you almost don't know what you're looking for until the graph reveals that to you. Here's what's really interesting. On the bottom here, what we're looking at are dates, okay? So this is 2016, and this is up to July. Over here on the side is supposed to be time. This is chart.js, and I learned chart.js about 3 weeks ago. So I have no idea what I'm doing. I tried to convert it into 24-hour format on the side, but it's actually not correct. Let me tell you what this chart actually reads. Right here-ish, is about 10 p.m. Central Standard Time. Okay? Right here, where it picks back up, this is about 8 a.m. to 7 a.m. Central Standard Time. What does that tell us? They're in Texas. That's right. Or they are in the Eastern Time Zone. They are most likely in Central Standard Time or Eastern Time. Most likely. They're probably not in Mountain Time, because that would be a bedtime of like 9 o'clock, and they're definitely not on Pacific Time, because that'd be a bedtime of 8 o'clock and waking up and starting tweeting at 4, and that definitely doesn't sound like a developer to me. Except for a couple of nights, like right here in January, this is like 4:30 a.m. I don't know what Horse.js was doing, but there was a big party in January. Also, this one here, this was also a late night. I don't know, not sure what's happening there.
New Year's?
It could have been, yeah, exactly. But other than that, they're getting a good 8 hours of sleep. They're not active at night. Good for you, Horse.js, healthy lifestyle.
Making good choices.
Okay, so the next thing we want to do here is we want to look at the original tweets, the quoted tweets. We're going to do the same analysis on those tweets, okay? So here's those tweets. Now, what you'll notice is that it looks kind of the same, okay? We've got this big opening here. It's a little bit more populated, but it looks remarkably the same. What can we glean from that? Well, we could assume that possibly Horse.js is quoting people that are in the same time zone. So they're quoting friends, people that they know, people that live in close proximity. Maybe. Again, we're making assumptions from the data here, but we don't know anything yet. At this point, I said, okay, well, let's do this. Let's overlay the horse data on top of the original data and see what we get. I'm not sure what I was expecting to find. That just sounded like something you would do with a chart. So this is what we've got. Now, this is interesting. The blue dots are the original tweets, okay? The red dots, or the pinkish dots, are horses' tweets. Now, on accident, I gave these things a transparency of 0.5 because I thought it was pretty. But that actually was interesting, because what you'll notice is there are some places where it is pink, bright pink. You see there? You see there? You see there? You know what's happening there? What's happening there? Same time. These tweets are occurring at almost the exact same time, some of them within seconds of each other.
Day doesn't lie.
That is awful quick. Just saying. So from this, we made this assumption that, okay, if the tweets are very close together, let's say 60 seconds or less, it's highly likely that Horse.js is following those people directly. Now remember, I'm operating under the assumption that this person sees the tweet and then tweets as Horse.js, okay? So I said, let's pull out all of the tweets that occur within 60 seconds of the original tweet. So let's do that. There they are. Okay, you'll see that there's like this one over here. Again, I told you I'm terrible at Chart.js. I'd like to apologize to the Chart.js people. Their product deserves better than me. Okay, so there's not a lot of them, okay? Now, if we spread this out to like 5 minutes to 10 minutes, it starts to get more interesting. But then, I mean, that's a lot of time on Twitter, y'all. 5 minutes is a ton of time. The other thing is that the analysis that we then did from here is we said, okay, for each one of these people, let's get all of their followers from the Twitter API, okay? And then we can compare those followers and see which followers do those accounts have in common, and that's how we're going to get them. And that was an incredibly difficult task. Here's why. Brendan Eich was one of those people, and that dude's got like 200,000 followers. Wes Boss was one of those people. That guy's got like 200,000 followers. And what we really quickly learned is, first of all, the Twitter API just rate limited the crap out of us. I mean, it just all day long. So that was number one. So basically what you'd have to do is you would test, but then once you hit the rate limit, you just have to stop for 15 minutes and wait. So imagine that as a dev process.
Right? Sometimes that would just end our day. We just end our day. It's like, oh, rate limit happened again. Let's just go be done.
See ya. All right, and so what we did was we had to set up these processes that would recover by themselves. So we did that, and here's what we found. All right, so after all this, what do we know? Horse.js is probably in Central Time or Eastern Time, or the rest of it was a vast waste of my time.
So when it comes to frequency analysis, I don't have as good as a definition as Burke does, as Burke did for time series or for the time series analysis. So I'm not going to give you an example, or I'm just going to show you the example of what frequency analysis is for, as it relates to our project, our project Horse. So one thing that we did is that we ran an aggregation query to find out the people that Horse.js had quoted more than 5 times. And this is pretty much answering the question, who does Horse.js like to tweet? Who does Horse.js like to quote? And so from this, we got some really interesting, some interesting data and some interesting results. So if you notice to your left, yes, your left here, that there is somebody who has been quoted a lot of times, and then there's also a cluster of people after that have been quoted pretty often as well. And then notice that as you move over to the right, that it starts to level off a little bit, So it seems that Horse.js has a circle of people, or whether friends, or maybe they are just a super fan, or maybe they are just or maybe they have that private list. I don't know. I'm still convinced that they might have a private list. But anyway, so we kind of focused in on that right on that high number of quotes, that occurrences of quotes per account. And we took a little bit closer look at that, and we used the metadata from those tweets to gather some more info. You want to talk a little bit more about that, Burke?
Yeah, absolutely. So it's important to note that here we kind of decided that Horse.js probably tweets themselves a lot. Again, because it would take a lot of restraint not to do that, and we just feel like that's not who that is. that to us just does not, restraint does not sound like Horse.js. So what you're looking at here is a map here of all of the people that live in either Central or Eastern Time. There's only 6. Of all these people, and yes, I know the names are blurred at the bottom. We're trying to obscure some data here. Of all of these people, only 6. One of them is in Texas, and there are 5 in the New York area. All right. So from this, we can again make a few assumptions about Horse.js. We could make the assumption, and we sort of did, that Horse.js probably lives in the New York area. Also, of these other 4 people that are in the New York area with them, almost all of those people are on the left side of this chart. So it is highly likely that Horse.js is in New York or the New York area. They have a group of friends in that area. They are quoting those people because they're friends, and it's funny. So we decided from this that Horse.js lives in the Eastern time zone, which took us to the next part in which we learned about some machine learning.
Yeah, so this is the output of the text analysis that we got. And so, like I showed you before, we put all our text analysis in a separate collection, ran an aggregate query. I got really good at aggregation. If you ever need any information, I had never used MongoDB before, so it was a learning experience for me.
Jasmine's going to start a consulting service for MongoDB aggregation queries.
And what we did is we ran an aggregation query on all the keywords. We wanted to kind of figure out, this is kind of answering the question, what makes Horse.js tweet or quote specific tweets? What are those keywords that makes Horse.js want to quote a tweet? And if you take a look here, so on the left here, the first 2 there are kind of givens. They're JavaScript and JS. And I feel like that's kind of like, even though those are blurred out, I think that those are probably a given. You would probably assume that those would be first 2. And then there was some in here that were actually kind of surprising. For example, Node was a little further to the right. And that was and then also there was, which is actually kind of interesting because it actually I believe came before. There was more NPM than Node.
Significantly more NPM
than
Node,
it was like a little further apart from each other on the chart, which is actually really interesting because you would think that they would kind of be like a little bit more equal because like, when I think of Node, I think also of NPM. So that was a little interesting. But yeah, so the interesting thing about that is even though that we didn't really gather too much about who Horse.js is from this chart, we did kind of confirm some of our assumptions. For example, we assumed that Horse.js is a web developer, and the keywords that we got from our aggregation and this chart kind of confirmed some of those thoughts.
Right, and once we figured out who it was, there was actually a key piece of evidence in here that we're not showing you that was actually like, yep, of course it is.
Mm-hmm. All right. So the last thing we took was the sources.
And this one's super interesting. So remember we talked about whenever you commit a crime, there's 20 pieces of evidence that you leave behind that point directly to you. This is it. So whenever you tweet, just FYI, there is a sources property that you are sending that is the origination of your tweet. And that could be the web, that could be your device, your tablet, whatever it is. You send a source to Twitter, and Twitter records that source. And Horse.js is no exception. It recorded that source for them. And lucky for us, that source was kind of interesting. On the left, we have the web client, and on the right, we have Android. Now, here's what's really interesting. Of all those people in the chart that we showed you before, there's only a handful using Android. And of all the 6 people that were our suspects in New York, there's only 1. And this was the moment at Friday where I said to Jasmine, oh my gosh, we got him. So what do we know? We know they're located in New York. We know that there are certain subjects that they tweet about more than others. We have obscured those results from you. We know that they are one of our 6 suspects. And we know that they use Android. So with that, and some key information that we have not shown you, otherwise you'd be able to piece this together for yourself. Are you ready to find out who Horse.js is?
So we kind of have also have a public service announcement. If you decide to, do this, repeat this experiment for either HorseJS or another anonymous Twitter account, we just want to let you know that doxing is not cool. If you're going to do it, please be sure to protect people's identities. It's not fair. Don't bring a lot of unwanted attention to people who might not want it. So yeah, just be good, ethical.
Yeah, exactly. Yeah, if people want to remain anonymous, let them remain anonymous. We reached out to HorseJS and we said, hey, gotcha. Is it okay if we get up on the stage and say your name? And they said, yes, absolutely.
Yeah.
So we are here with permission.
Yeah, so I think we're all set. We're ready to reveal who HorseJS is. So before we do, we're going to put our horse mask on.
Here we go.
Here. All right.
Do you want to do a selfie?
Yeah, we're going to do a selfie. We're going to do a selfie before we do it. So, okay.
Oh, this thing smells so bad.
Yeah. And my hands are going to be smelling like rubber. So I don't know if we're going to be able to hear us, but we're going to try. Hey, can you still hear us? Really?
I can't see. Where are you?
So now we're going to... This is impossible. Oh, wait. Oh, you need... Okay, hold on.
Where are we? Okay, here we go.
Okay. All right. We're going to take a selfie, so 1 second. Oh, wait, I got to...
Reverse the... There we go.
Okay.
Oh, gosh. There we go.
We're good?
Yeah.
All right, here we go. 1, 2, 3. Okay.
Yeah.
Woo! All right. So we're ready to reveal HorseJS. So we need. So can
we can't. I don't think they can hear you. It's muffling. The horse
really?
mask is success. There we go.
Okay, I'm gonna keep it right here.
It actually looks better as a hat, I think.
So can we have a drum roll, please? HorseJS. All right.
Stop!
Sorry.
Stop!
Sorry. We're out of time.
Sorry, we have to do closing
We
remarks.
really need to get Brian Sinclair up here for
Yeah.
closing. So, sorry, y'all.
Thanks for not outing me. No. I thought you liked me. No, all right.